Hello, today we are going to discuss the trouble with space debris. Space debris, commonly known as space junk, is an existential problem that threatens human life, terrestrial technology, and orbiting technology. This problem has been building for decades, and the point of criticality has come and gone. We need to do something about space debris yesterday. Our presentation will cover the orbital debris problem, including the short-term and long-term population growth. We will also review some risks to space missions and then touch on some orbital debris mitigation methods, including space situational awareness, space traffic management, some policy measures, and also some technical concepts that we can implement. You may be asking yourself, what exactly is space debris? I mean, most of us have heard the term, but it's not very specific as to the precise definition. So space debris, otherwise known as space junk, is any human-made object in orbit around the Earth that no longer serves any useful purpose. Now the emphasis is on human-made, so if you look at the chart here, you can see that rocket bodies, spacecraft, breakup fragments, pieces of aluminum, paint, batteries, things of that nature would be considered space junk if they're no longer functional. Something that's natural, like a meteor or meteoroid that lands on the Earth and goes through the atmosphere, would not be considered space junk. You may be wondering just how much space debris is really up there. Well, let me tell you, it's a lot. Combined Space Operations Center, also known as CSPOC, tracks over 23,000 pieces of space debris that are the size of a softball or larger. Think about that for a second. We're talking a diameter of at least 10 centimeters, moving at a speed of roughly 35,000 kilometers per hour. Now imagine that hitting your spacecraft. The next size down, which is a marble size or larger, is at least 500,000. And that's really just a guesstimate because we can't track that. Going down even further, a dot size, say roughly 1 millimeter, think of a grain of salt, is in the order of 100 million pieces. And even a piece of debris the size of a paint flick will go ahead and cause havoc to your spacecraft. Let's go ahead and go over some threat examples here that are actually true to life cases. So we have one here with the gravity gradient boom of an operational French satellite was cut in half by a piece of debris that was tracked, and this is all the way back in 1996. We had the fully operational Iridium 33, which is a communications satellite, was destroyed by a retired Russian Cosmos 2251 in 2009, not too long ago. At the end of the space shuttle program, the loss of crew and vehicle risk from the MMOD impact damage were in the range of 1 in 250 to 1 in 300 per mission. Think about that. That's outrageously high. The current probability of an International Space Station crew evacuation due to orbital debris impact is approximately 13.7% over a 10-year period. May not sound real high when you read that number, but if you're on the station, I'm sure it's in the back of your mind. Here are a couple more examples of some damage from space debris. One was a retroreflector, which is used to track satellites by reflecting either sunlight or a laser beam. And a Russian retroreflector Blitz was damaged and shed a piece of trackable debris in January 2013. And then the European Space Agency, or the ESA, their Sentinel-1 was hit by a piece of small debris and led to some power loss on a solar panel. There are two types of problems associated with orbital debris. One is the long-term problem, which relates to the population of debris increasing over time, which has been happening over the last several decades. And the fear here is that a chain reaction occurs, which is called the Kessler effect, and debris begets debris, and we have no access to space at that point. The short-term problem is a mission end risk problem for most of the space operators, and that involves the smaller debris that's not tracked. Because of the quantity of the smaller debris, most missions are going to encounter it. So this becomes a specific mission issue for just about every mission going up. You may be asking yourself why we haven't addressed this problem earlier. I mean, Kessler had made this forecast back in the 70s, and this is not something that was unknown for decades. The short answer is that the United States and other governments have tried to address it. And as a matter of fact, there have been a multitude of mandates and policies that were put into place to attempt to alleviate the problem. However, they just weren't successful. And it's also difficult to stop space debris when only a handful of countries that are putting objects in space are actually following the rules. Now, going back to the short-term problem, the mission end risk for most of the operational spacecraft is driven by the smaller millimeter-sized debris that we are not able to track. And the reason why is because orbital debris follows what's called a power law size distribution. So it means that there's always going to be significantly more smaller debris than large debris. Therefore, the mission ending risk is almost always dominated by small debris impacts. We have what we are called conjunction assessments and potential collision avoidance maneuvers, or a CAM, against the tracked objects. But unfortunately, the smaller objects are not tracked, not because we don't try, but just because we don't have the technology to do it yet. While there are a number of companies and government agencies that are searching for a true orbital debris remediation approach or a cure for orbital debris, about the best we can hope for at this point in time is prevention. So there's been a big push to develop different types of rules and policies and also technologies that can be attached to spacecraft pre-launch that will allow the spacecraft to be removed when the mission life cycle is complete so that it's not left in space or in orbit creating more debris. I'd like to continue our talk about space debris by watching a short European Space Agency video. It's a little over 4 minutes, and it goes into some of the problems that spacecraft operators have with debris. And after it's finished, then let's go ahead and head over to Learning Station 2, and there we'll learn about space situational awareness, which is basically how we know where the debris is, how we detect it, and how we can avoid it. And this is going to be a presentation given by a colleague and friend of mine named Mariba Jah, who's the co-founder of Privateer Space and a professor at the University of Texas in Austin. Then we'll go over to Learning Station 3 and investigate some of the pre-launch government policies that have gone into effect just last year, and a few technical solutions that I've been involved with for pre-launch mitigation methods.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed a space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.